Let's solve a quadratic using the root method. It's also called reverse FOIL. So let's get started. Let's go with x squared plus x minus 6 equals 0. And the way we're going to find the roots of this polynomial is to factor it into two binomials. We kind of set it up like that. Okay? So these going to be binomials. What that means is each of these factors has two numbers in it, okay? And the first two numbers are the product of x that creates x squared. So that's just simply x times x, because x times x is x squared. And the next two numbers are a little bit more difficult because we have to look at the value negative 6, and we're looking for two numbers that have a product of negative 6 but sum to 1. We have a product of negative 6 but sum to 1. So let's first look at those values that have a product of negative 6. For example, negative 6 times 1 is negative 6. So that has a product of negative 6. Also, 6 times negative 1, that has a product of negative 6. And negative 3 times 2, that has a product of negative 6. And let's see what else. We have negative 2 times 3. That'll also give us a product of negative 6. So these are our four possibilities, okay? But we need to find that possibility that also has a sum of 1. So what I mean by that is, let's look at this one first. Negative 6 plus 1 would give me negative 5. So that one doesn't have a sum of 1. Let's look at this one. We have a positive 6 minus 1. Well, that will give me a product of plus 5. So that's not our choice. We're looking for one that has a sum of 1. So we have negative 3 and 2. Negative 3 plus 2. Well, that gives me a sum of negative 1. So that doesn't work. So it must be this last one. Negative 2 plus 3. Well, that gives me a sum of plus 1. And that is exactly what I'm looking for. So that tells me it's these two numbers that go in that other position. All right, so that's negative 2 minus 2 goes here. And a plus 3 goes here. Wow, ooh la la, we got her factored. Okay, so what that means is this equation and this equation are mathematically identical. All right, but the cool thing about this, here's the first equation that we started with, right? This is our first equation, and this is our second. And the cool thing about it is the two equations are equivalent. But this one, this second one, I can readily see what the roots are. You get used to this over time. You'll be able to just look at that and tell what the roots are. What am I talking about? Well, I know I've got two factors here. One of them is x minus 2 and the other one's x plus 3. And I find the roots of the equation, the zeros, the answers, by setting each root equal to 0. So, for example, I set each factor equal to 0, x minus 2 to equal 0, and I set x plus 3 equals 0. So I'm setting each factor equal to 0. Here I'll solve by adding 2 to both sides to get x equals 2. There's my first root. Here I'll subtract 3 from both sides to get x equals negative 3. There's my second root. Okay, so notice, what I want you to notice is these are the zeros. If I plug negative 3 back into this equation, I could do that to check my work. I would see that, in fact, that negative 3 times to the power of 2, which is negative 3 times negative 3, or positive 9, plus negative 3 minus 6 would equal 0. So these are the values of x that make this equation true. Fine, good enough, but moreover, what I want you to notice is this the root, it looks like a 2, but it's actually a minus 2 here. So the form of the roots are x minus root 1 times x minus root 2 equals 0. So the minus sign is kind of built in. So for root 2 came out as negative 3. Looks like a positive 3 here, but it's actually a minus 3. You see, I'd have to write the equation as x minus 2, that's fine, times x minus a minus 3, which is the same thing as x plus 3, equals 0. And that is how I have it in root form, if you will. So I can readily see the roots are positive 2 and negative 3. Well, that was fun. Thank you for joining me. Ooh la la.